Dad joke writer and AI scientist at Deepgram. On the AI show, we talk about all things AI. What is it? What can you do with it? How does it affect you? Where is it going? We're live and ready to answer your questions. Comment on YouTube and Twitch or tweet at Deepgram AI to join in. Today, we have the question, our big question today.
Big question.
Yep. How will data influence the future of machine learning?
How does data influence? You know, it's a pretty key thing, as we've discussed many times before.
Well, data, you have to have the trifecta, right? You got to have computing power, you got to have data, you got to have good models.
I think we're starting to see some trends here. What do you think about how like a normal machine learning program goes, or problem goes,
Well, I mean, if you have a small amount of data, then you use some like simplistic models and things like that. If you have a large amount of data, you can probably, you probably will have to use a lot of computational power, but also it can shape your model and make it more intricate, more nuanced, is usually how that goes. But it isn't necessarily that the bigger the data, the better your model is going to be or something like that, right?
Yeah, no, definitely not. Data plays a key role, and size of data definitely helps if you've got more, but there's a lot more that goes into it. But we're starting to see a lot of these problems kind of evolve along kind of a standard path. We've seen this a couple times now.
How do they evolve?
How do they evolve? It seems like there's a couple key points in the life of a machine learning problem. At least I've noticed this. And have you noticed some of these?
I probably. I got it. I don't know though. I'm not sure what you're thinking.
Well, here's what I'm thinking, because I'll just lay it all out on the table right here. Right. In general, we see a problem evolve. We see a problem emerge that people finally recognize as a problem. And I've noticed, and a lot of people have noticed, I think, that pretty soon someone publishes a data set that becomes the data set that everybody kind of works their magic against to try to attack this problem the first time. Like the classic, handwriting digits, or image recognition. There's a lot of classic data sets that once those were published, people could try different algorithms and compare them, et cetera, et cetera.
Yep. So if you're drawing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just writing it, hey, can you recognize those?
Yeah.
That type of data set. Maybe something simple, or another simple one, like what category does this fall into? Is it a human? Is it an airplane? Is it a cat?
We've talked about like CFAR data set and stuff like that. But those standardized public data sets really help frame the problem. And then following that, you get some tools will generally come out. We're seeing TensorFlow, PyTorch, all these standardized tools kind of follow along. But, people start standardizing, ImageNet and things like that, like, hey, here's a way to attack this problem. And we just see the evolution of this problem go from understanding there's a problem, classic data sets released, a bunch of people and academic papers get published, and then some standardized solutions start coming out, and you see the polish on the solution start evolving over time.
Yeah, and the progress is rapid. Like you can look back and be like, wow, how did so much get accomplished? But it also still takes place over the span of decades, right? Yeah. Like MNIST, the handwritten digits, was like 20 years ago, right? Maybe a little longer, but CFAR probably similar age, at least close. Not quite as old. ImageNet 10 years roughly, et cetera. So
yeah, it's pretty cool to see that we've had enough of these problems that we can kind of see those arcs going through them, and from that we can see new problems. Kind of gauge where they're at. It's like charting a star. It's like this is how old it is based off of how it looks.
That's a good point. Yeah, that's sort of based on how hard is the problem, how easy is it to get the data, how like scintillating is the data. Is it something that you can find for free, easy on the internet, nicely labeled and things like that. Images are like that a lot. It's kind of easy to find a lot of images that are labeled. Not super easy, but you can search for tool or something and you'll find tons of pictures of tools, like, okay, that's pretty easy. But there isn't an easy way, like for a speech recognition, to say the word tool. Give me all the examples of everybody saying that word. It's like, that's a harder problem.
Well,
right?
By the time that becomes easy, it probably means that the problem has been
solved. Yeah.
It's been solved, which is the cool thing. But it does bring up like these, as the problems have gotten tougher, they're still kind of following that arc.
Well, it's not trivial though. Like the reason that you could search for a tool and get pictures of a tool is because people would label them.
Yes.
Like here's the caption: a picture of a tool.
Yeah.
Oh, okay. So
Yeah,
that probably means that's what the image is.
Yeah.
But that's not how it goes in audio. Like if you just recorded your meetings or something, that you're not going to sit down and label all the moments.
No. Well,
Not generally.
Yeah.
Usually not.
There are more and more academic sources that are helping to do that, and the problem is growing over time. But that is just hard. To the viewers at home, if you want to appreciate how hard speech is, just say something in your own voice for 5 minutes and record it, and then transcribe what you said. And see how long it takes.
Try to get it exactly. You already know what you're talking about. You know all the vocabulary words.
You're the one who said it.
Yeah. You know your voice, right? And then you're like, wow, this takes a lot longer than I would expect.
Yeah, that was a lot.
And it's way more boring than I would expect as well.
Way more boring.
Yep. But like the speech data sets, the very first speech data sets were somewhere in the early 90s, essentially. And then kind of early 2000s, some bigger ones came out. There hasn't been a big public speech data set, though, that has been released, like a la, ImageNet or something like that.
Yeah, there's been a couple that are starting to pop out. But yeah, it's been hard to find that huge data set that can finally give you enough to get some practical results on. One that we've played around with a lot, like Fisher, is finally large. That one's large enough, but you got to pay for that.
Yeah. Well, and it's large enough to do something, but is it large enough to like solve the whole problem? Like, no. So, but I think that gets back to like how does data shape machine learning, or how does that? Is it fairly easy to get? Is it pretty freely available? Is it all that hard to label, and is it a problem that's like worth solving or sort of interesting to solve, right? And you have to kind of have all of those things, and then the data sets kind of pop up.
Yeah, and there's one more angle here that that's been popping up more and more lately. That in the early data sets we really just didn't concern ourselves with, and that is the privacy angle of the data set. As these tools are getting better and better, as we're putting more and more attention to them, and as the amount of data grows, even what you might think are trivial data sets become big privacy concerns. You thought you were anonymizing your history here, and suddenly now everybody knows what movies you've been watching. You remember the Netflix prize?
Yeah. There's a Netflix prize. Maybe 8 years ago now, 7 years ago, something like that. It was a machine learning prize. It was like get $1 million if you're able to make a recommendation that's better than 90% accurate or something like that. It's something along those lines. But recommend movies to people, and then and if that would actually match with the taste and something that they would like, then that's how you gauge your accuracy. Like, okay, great. But they ran that. A bunch of different academics and companies and whatnot went after that problem. Yeah,
and it kind of did follow the same curve we were talking about earlier. That the big data set was put out there, and a bunch of different people, academics, started throwing a lot of different answers to it. They finally got to kind of an acceptable solution. Now, from what I understand, the solution that won wasn't what they actually implemented, because it was a fairly complex, heavyweight thing. They took a more stripped-down version of it. But it does show that arc, and it also shows how privacy really came into this, because afterwards, the security researchers got a hold of this data set, and they started linking real people back to these anonymized movie records.
Yeah, it's like, can you guess, even with 30% accuracy or 10% accuracy, like who this person is based on just the movies that they like?
And this is a growing trend in these data sets, and it also is a growing challenge, because, like we said, when you publish those data sets, it helps frame the problem. But if you're getting challenges publishing it because you're got privacy concerns because of the data, that could put the brakes on a lot of problems that might be solved. There's trade-offs here. I'm not advocating throwing out privacy. Let me be very clear about this.
In order to make AI work well, you need data. And how do you get data? You get it from people. People say things, or people do things, or they take pictures of things, or they write things, or whatever. And so laws, surround the use of this data essentially, and it's been fairly free up until recent times. GDPR happened in Europe, and so that means that you have to like very explicitly give permission to use your data rather than it kind of defaulting to being able to use the data. The US is still pretty free about this. And people are probably going to have to choose in the future or now in the next ensuing years, like, what do we want that to look like? Do I have to give you my data in order to use a very useful service? Yes or no? Is there some other protection in there? Like, how does that work? But you're probably giving up, the way that it'll probably work is that if you say no, then you probably are giving up some functionality there because now it can't learn from you.
Yeah. So one thing, you and I have talked a lot about is sort of a symbiotic evolution of these things. What you see is, huge privacy concerns, through big data breaches and things like that. And, you get a swing on the other side, privacy laws start coming in, which shapes the next set of concerns, which shapes the next set of laws. And this is what you see everywhere. And we're honestly, we're kind of at the beginning of this. We're starting to really see, big legal entities come in and move and start doing this. And they think they've got enough information to start building laws and stuff like that. And this is the beginning of a process that's going to take decades to shake out. So it's a huge thing that you have to pay attention to with dealing with this.
This has been in the news recently with Apple, Tim Cook, Apple CEO Tim Cook at a data privacy type conference and giving keynote there and sort of lampooning a lot of the other tech companies saying like, hey, you're stepping on people's data rights.
It's interesting to see a very large company, especially one with access to so much
of data,
personal data
with machine learning groups
and moving into huge fields like personal health monitoring and stuff like that, which I mean,
they do a lot of that.
They do a huge amount of that.
They have always they've always planted a flag in the ground and said like, we are security conscious, we are data privacy conscious, etc. Apple has been, you famously saying like, hey, we're not going to give you the keys to unlock somebody who's been arrested, their iPhone, things like that, right?
Yeah, I think they just shut down a major tool with the last iOS 12 and above upgrade.
Yeah.
So they've been doing this, but this is the jaded side of me. I'm gonna have to. I don't.
You really believe it?
Well, I mean, it's kind of hard to see big companies saying that they're altruistic. I'm not saying Apple's evil or anything like that. I'm just saying you always have to take a grain of salt with a big company movement. That's a well thought out movement, and they have some, I'm sure, under the hood ideas that they're not telling everybody.
and there's a competitive landscape that you're in as well.
Yeah.
Hey, you're a company. Other people are getting data, and maybe you are taking a stance so that you don't. Okay, now you have a competitive disadvantage, and maybe this is why he's saying those things, so that competitors like Google, Facebook, etc., have more heat put on them from the government.
Yeah. Well, and also if you come out early as an advocate, knowing that it's going to go down the route of tighter and stricter laws, maybe you have more influence. Maybe you can shape those laws more in your favor.
Yeah.
And Apple definitely would want to shape those laws in their favor. Any big company is going to say, hey, make it work for me as best as I can.
Yep.
So you come out waving the flag of privacy first, and you get a little bit more of a voice in what's inevitable.
Sure. Yeah. Well, you want to build a company, or you want to build products, etc., that people aren't going to hate. They're going to like. They're going to want to keep using, and they provide value and things like that. You just have to find that balance. Apple will have to find that balance. Every company will have to find that balance with data and the models that they build.
Yeah, that's true. But it is interesting. Again, going back to the general theme here, seeing the arc of these problems and seeing, that simple arc is getting more and more complex by the day. But the complexity is also growing with
understandably,
and the complexity is growing with the complexity of the problems we're tackling. when we first wanted to figure out, is this a 1 or a 7? You know, is this a a horse or a pig? When they first came out, those incredibly hard problems to solve, and now it was like, yeah, of course that's easy, right?
Yeah.
We're tackling really deep, hard problems now. Like another great data set that just came out, Twitter.
Yeah. Text
Right?
data sets, Twitter. Yeah.
Yeah, that's a big one. And it hits all of these fronts, right? This is talking about really complex social issues and really complex technological issues. All wrapped up in a big brand new data set that we'll see if it becomes adopted.
Yeah.
As sort of like a cornerstone for figuring out this problem. But the problem of basically weaponized social media.
Yeah.
How do you fight that? And maybe we have a first data set on there, but there's a lot of concerns with that.
So what do you think we should, or people should do from like a policy perspective? Like what should exist in the future in order to enable an ideal sort of landscape for AI to flourish, but privacy to still be a thing?
Yeah. What's the balance? Man, this is so early. Like throwing a dart about what the right balance is really, really hard.
Yeah, it's like 1900 trying to talk about electricity or something.
Exactly.
Yeah.
I mean, I think first of all, without talking about restricting what is and isn't there, Susan's personal take is openness is the number one thing. Being open about what data is being collected and what it's being used for. I'm not saying restrictions or anything like that, but that will help
let people know.
Yeah, that'll help frame the conversation and help educate consumers and individuals, and companies. And that way we can go into an informed future and make more informed decisions.
Yep.
I can guarantee you that whatever's being hidden right now eventually will come out.
Yeah.
And that's the nature of the digital age.
Yep.
And if you're more open right about now, it'll go a lot easier when the harder privacy laws inevitably start hitting.
Well, if you were to ask me to make a prediction, hey, how are people going to feel about this in the future?
Can you make predictions?
Yeah, I can make a prediction. How are people going to feel about this in the future, or like what's going to happen? I think if you just look back into the past, year 2000, internet hits the world, in a big way, essentially, and everybody's like, afraid of it. They're like, I don't know if I'm going to go on there. Is this thing watching me? Like, I have a webcam. Oh no, it can see my entire life. Should I put my credit card in here? I'm not going to trust anything. How could I get anything through the mail, through eBay, and trust that whatever, So there's a lot of things that have to be figured out, but they get figured out, right? And so similar thing with AI, a lot of things that have to be figured out. Do you have to fear everything? No. Are people going to fear everything at some point in time? Yes. Are they going to be resolved? For the most part, yeah.
Yeah. Well, fear is not a good way to approach the future, no matter the problem.
Yeah.
Right. It should be a motivator to understand, but not to, stop you from going into the future. Because no matter what, there's only really one guarantee: the future is going to happen.
Yeah.
So you can either be part of shaping it.
Yeah.
Or you can hide in the
back
corner
and watch what happens. Yeah.
you know.
So but to answer our big question, how is data going to influence the future of machine learning? Okay, so there's got to worry about privacy. You got the different types of machine learning. We talked a little bit about text, audio, images, other stuff. But what's the future going to hold?
I think that we're going to see more and more of these big data dumps trying to be the cornerstone of solving a problem.
Like a jumping off point?
Yeah, jumping off point, especially, honestly, from bigger companies, because now just the fact that Twitter released it, now we call it, I'm already calling it the Twitter data set.
Yeah.
Their name is out there,
yeah.
and they're looking, like they're doing something about this problem. So it's good kind of PR, although it's really challenging. It can be a disaster if you do it wrong.
Yep.
But we're going to see more of those cornerstone data sets go out there, help define these problems with data, data defining the problems. And that's a big piece of what's going to shape what the machine learning world looks like 5-10 years down the road.
And this is a really interesting part of AI in that the data that is collected, labeled, used to train models and things like that has transferred very heavily from being small academic data sets to very large data sets that are captured by companies and used to build models. And so this is why you see like talent moving from academia to big companies, et cetera. But like that's not really going to end because that's where all the data is. The big companies have the big data, and in order to do AI well, you need big data.
Yeah, people that want to solve problems want to solve problems, and they go where the problems are interesting.
Yep.
And early on, it's interesting in the public sector. Later on, it becomes interesting in the academic world, right? It gets its seeds in academia, flourishes in public, and then goes back to academia.
Yeah. I think so, because a lot of the baseline problems will be solved. People will sort of be tired of it. It'll be very very commonplace that the AI system and whatever, and we got our data flywheel and we're collecting what we're doing all the thing. But what's the new good stuff? General AI or whatever, where's that going to be seated? Maybe in the companies, but probably more like there'll be some kind of data partnership with academic institutions or something like that.
You know what? An interesting kind of area that data, this is pure speculation here, but then data could really start playing a different role is government supplied data sets that you must conform to if you're going to release something, like
like it has to fit these rules.
Or you must have learned from this data set. And we're going to test you against your ability to deal with these data sets.
Kind of an adversarial, like if you can't deal with this, then you're not a good enough model.
Well, think about judging. We'll make up a hypothetical doctor program, and they have their test set of diagnostic cases that you must pass.
Like cancer, yes or no.
Yeah, this becomes, how to board certify an algorithm.
Yeah. Agreed. Really good point. Machine learning models in the future will probably be tested a lot like humans are now. Agreed that there's sort of a curriculum, and tests that you should pass, and maybe you specialize in certain areas. But if you go work for one company, the things that you learn there will probably also be transferred to other companies. And maybe it's not like trade secrets or something like that, but sort of underlying ways that humans work or something like that. That's what happens for humans now. You go work for one company, fine. You go leave, you go work for another company. Did you forget everything that happened for those years that you worked at that one company? No. So you bring those along with you, and people will start to think of models that way.
Yeah, it's a really interesting world just on the data side. I mean, just so much that goes into curating a really good data set, publicizing it, and getting it accepted, and all the areas. So Scott, what do you think the future of data sets are, and how they're gonna shape? We kind of talked about that a little bit. What's your speculative?
I think it's going to be interesting. I think we're just in the very beginning stages. It's like the first railroad was built across the U.S. or something. Now there's going to be 3,000 railroads. It's a similar type of thing. Hey, the first telephones were a long time ago, but it took a very long time after that until everybody had a telephone, et cetera. It's just going to. It's going to work its way into every part of life, and at least from my perspective, people shouldn't be too afraid of it because it's going to make your life so much easier. You are going to be so as long as things are like the path is taken in a way that isn't crazy, which like companies are pretty non-crazy now. Like they don't want to scare you off from being their customer or anything like that. Then it's like, hey, this is going to evolve. It's going to make your life way easier. Things are going to be more efficient, etc. And then you'll just be very glad. Similarly to like text messaging or Facebook or something like that. Hey, you're giving up all this data and some privacy and things like that. But like your life is so much better now that you can connect to your network that is spread across the world, essentially, right?
Yeah, I mean, much as we are definitely challenged by the privacy world it is today, no one is talking about giving up, their connectivity. Right. Yeah. I should say no. I definitely know people that say they're going to they're going to drop off social media. They're going to drop off whatever. Yeah, and you never hear from them. Like, wait, maybe. No.
Yeah. But it's like, are you going to stop using Google just because they use your search terms to help train their models to serve you better search terms? Like probably not, right? And so Anyway, but. Yeah, I think, I mean, data obviously plays a big part now, but it's going to play a very big part in the future. You'll get your baseline set over the next few years, but then there'll be all these offshoots that, you know, the rest of the world and life just starts to become easier because you get that labeling flywheel going. Hey, here's some data. Hey, we labeled it. Hey, we trained a model, and then it did this task, and then people become used to it. And then you're like, whoa, this is awesome. I don't have to do all these menial tasks anymore.
Yeah, well, and it gives you that bootstrap. So another one
Yep.
more final kind of like, you know, interesting aspect of all this is people don't realize it, but the first hour is the hardest hour, right? The 10,000th hour is way easier than the first hour. And even if the first hour isn't as targeted as you like it to be, you know, just having someone have kicked out that first hour for you saves you so much work and effort mentally, because now it gives you a structure, what the 10,000
Yeah, it's
hour
something to
might
build
look
off
like.
from. So like if you just have an example, you have a template, you know, and it's like,
so-
okay, maybe I'll add 1 hour from my time to make that. Now it's a 2 hour data set, and then it starts to build a community around it.
Yeah, these things are like little seeds.
Yep.
You know, these little data sets are just seeds.
You just got to form it in the right way, and then it grows.
Yeah.
Well, I think that's it for today. Thanks for joining the AI show. What questions do you have about AI? Comment on YouTube or Twitch, or tweet us at Deepgram AI. We're Scott and Susan from Deepgram. We come in peace.
We're certainly not robots.
Definitely not robots. See you next time.
Oh, wait.
Wait.
I'm
We
gonna
need
beat
to finish this. We barely got started.
Barely.